So, hi everyone. So, I am back again, your subject teacher. My name is Jabet Hinugin, if you do not know me yet. So, and welcome to Module 2, Chapter 2, which is we're talking about the normal distribution. And under that, we have 4 lessons. And first is the understanding normal curve distribution. So that would be our first topic for this video. So the previous video we already talked about random variable. I hope you already can distinguish between continuous and discrete. Okay, and also I hope you know now how to get the probability distribution. Alright, so our competency for this video is, or for this topic, is illustrate a random variable and its characteristics. Yes, that one, and construct a normal curve. So at the end of the lesson, you should be able to define, draw, state, and apply the empirical rule. So in this activity, don't need for you to answer as your assignment. This will serve as your activity for this lesson. So what can you see about these pictures here? What is this? What do you think is the answer for this one? What is this? Length, width. This is the square root, diba? Length, width, height, that is the volume. This one is what? Alright, so what can you say about these pictures that is on your activity? Sige daw, let's try with this number 1. What can you say about this one? That is what you call the what? This is, I hope it's correct, this is the area. Yeah. Is that correct? Area. Yeah, that is area. Next, how about number 2? That is norm. Norms. Oh, yeah, that is norms. How about the third one? What is your answer? It is in your basic calculus. Oh no, pre-calculus. It is on the parabola. Yeah, that the line that cannot intersect the x and y axis. It is almost there, but it will never ever connect, or it will never ever touch. Yes, this is asymptote. Yes, asymptote. This is asymptote. Yes, that is asymptote. Lines that never ever touch the x or the y axis. This one, what can you say about this picture? This is what we call symmetric. Yes, symmetric, and this one is bell. Yeah, we have here the bell shape. So these pictures here describe the normal distribution. We have the area, it is normal, and we have the asymptote, which is it is approaches to 1, but it will never before that one it will never ever touch that axis. And then it is bell shaped because it is normal, or it is and then it is symmetric. So, abstraction. Normal probability distribution is a probability distribution of a continuous random variables. It shows graphical representation of random variables obtained through measurement like the height, the weight of the students. So, it is a continuous. The percentile ranks of the A&D accreditation of equivalency test result of the all students or any data with the values of interval scale or real numbers. It is also used to describe the characteristics of population and making inferences. So, normal curve, remember the properties of the normal curve. Number 1 is the normal curve is a bell shape. Yes, it's a bell shape. Like that. Yan. The peak of the normal curve is at the center of which 3 measure of central tendency such as mean, mode, and median. So this one here, the center here, is what you call the mean. Yan. Is the center where the 3 measure of tendencies such as mean are equal So that will be equal to the mode. That will be equal to the median. Later on, we're going to discuss, I hope you already know the mean, the mode, and median. So the mean is the average, the mode is where repeatedly appear. Example 1, 2, 3, 4, 1, 2, 2, 3. So 2 is repeated, therefore the mode is 2. The median is you're going to arrange lowest to greatest or greatest to lowest, and then you look for the center. So like this, so it is even, so you just add the second and the third one, and so that is 2. 2 plus 2, that is 4, divided by 2, so the median is 2. So remember that you cannot get the median if you're not going to arrange it from lowest to greatest or greatest to lowest, vice versa. Next, about its mean 0, the normal curve is symmetrical to the center. Yes, here is the same to this side. Yeah. Okay, so the left is equal to the right side, or symmetrical. The tails are plotted in both directions of normal curve and is asymptotic with the horizontal axis. This is the horizontal axis. Yes, this is the horizontal axis. Asymptote means a graph is approaching to the specific line but it will never touching it. So, magpadayon to just like that, be like that. So, it will never ever touch, but it will be going to approach to this one, but it will never ever touch like that. That is asymptote. So, murag relasyon, charot, never mind. So, the total area of normal curve is 1. So, again, remember that probability distribution, the total is 1. So the same as in normal curve, the total is 1. The shape of the normal curve is based on 2 given parameters, the mean and the standard deviation of the distribution. The following are the 3 situations of a normal curve based on the said parameters. Okay, this is the one. Anyway, let's continue to this one. I'm going to further explain that to you later on, but we're just going to continue our discussion on the application, how to use that one. So let's have how to construct a standard normal curve. So it should be a bell shape, of course. Both sides of the tails of a normal curve should not touch the horizontal axis because it is asymptotic. It will never touch. Okay, so in the horizontal axis, use 0 at the center is located and use 1, 2, 3. So like this is the figure. So again, 0 is the center. The bell is shaped as symmetric, so the same. Tails never touch the horizontal axis. So as you can see, it will just approach it here, but it will never ever touch the horizon. So it will just approach it here, but it will never ever touch the horizontal axis. Okay? So both sides, right? Then the mean here is 0 and the standard deviation is 1. How did you get the standard deviation? Because it is here. So 1 plus 1, that is 2, then 3. So that the standard deviation, meaning the scattered part, is 1. So if suppose I'm going to use 2, suppose your standard deviation is 2, then this is 2, then you add 2 here, that is 4, and then you add 4, that this one should be 6. The same thing is here, it is negative 2, negative 4, and negative 6. That is how the standard deviation is used. Okay, it should be proportional. So empirical rule. So I'm going to discuss you this one. So as you can see here, the 68% of the data lies within the standard deviation of the mean here. 1 is 68, this one and this one. So remain as negative 1 to 1. That is the 68%. 95% is from negative 2 to positive 2. It covers the 68%. And the 99.7% covers negative 3 to 3. Again, it depends upon the standard distribution that you use. Okay, so let's have here an example. The score of a senior high school students in their statistics and probability quarterly examination are normally distributed with the mean 35 and the standard deviation is 5. Standard deviation is 5. Answer the following questions. What percent will fall within the score 30 to 40? What scores fall within 95% of the distribution? So we are going to make use of this empirical rule, but we are not going to follow this negative 3 to positive 3. We are going to follow the given, which is the mean is 35 and the standard deviation is 5. Alright, so as you can see here in your example, You can see here that this is not already 0, but it is already 35 because the given here is 35. Remember, the mean is 35. Then the standard deviation, you just add, 5, that would be 40. That's why then you add again 5 here, then that will become 45, then you add 5. That is the use of standard deviation. The same thing, of course, you're not going to make use of negative 40 because you are going to subtract here minus 5 here on the side, then the same thing as minus 5 here, then minus 5. Alright? So that is how you're going to construct normal curve. That's how you're going to construct this one, okay? Ma'am, what if, ma'am, if your mean is 20 and your standard deviation is 3? So if you're going to make use of this one, so your mean here, that is 20. Then you add 3 here, that is 23. Then you add here, that is 26. On the other side, you minus subtract 3 here, that is 17. You subtract 3 here, that is 14. And you subtract 3 here, that is 11. So that is how you're going to do it, alright? Okay, next. So let's answer the question. The scores 30 to 40 falls 30 to 40 falls between what percentage? That is 68%. That's why it is 68% here. Can you get it? How about this? What score falls 17 and 13? So this one, that is also 68%. Alright. Since 95% lies within the second standard deviation, this one, yeah, we have negative 3, negative 2, negative 1, 0, 1. Because we are doing or following the empirical rule, so it can be also seen, and that is our, we also use that one. So, since 95% lies within the standard deviation 2, this one, this is 95%, kani siya kani. Yan. That is 95% the mean, then the corresponding scores distribution is from 25 to 45. So 25 up to 45. That is the limitation. Okay? So I hope it's clear to you how to get the percentage using the empirical rule. Okay? How about example number 2? The district school nurse of Candelaria needs to measure BMI. So, she found out that the heights of male students are normally distributed with the mean. Remember the mean, that is 160 cm. What is the standard deviation? The standard deviation is 7. Alright? So, we have here 0, negative 1 to 3, and 1 to 3. So, we have here the mean, which is 160. Then you add 7 to the right side and subtract 7 to the left side. The same thing as what we did from the previous example, right? So, okay, so find the percentage of males within 153 to 174. So we are looking for 153 to 174. So remember that this one is already covered. Yes, this is already covered with 68%. Diba? We already have 68%. Now, if we are talking about 153 to 174, 146 is not included, right? Therefore, we cannot use this whole 95% because this part is not included. This part is not included. What is only included? This part, because of this 167 to 174. Therefore, this 68, you are just going to add this one. So you're just going to add 13.5 because it is just a part of 95%, not the whole. So 0.5, we have here 11, 6, 7, 8. So therefore, the percentage of male student whose height is within 153 to 174 is 81.5%. Okay? Alright? Can you get it? That is here. This is the answer. The height, complete answer. The height of 153 to 174 lies on the 81.5% of the distribution. Can you get it? So that's how you get the percentage. All right. Okay, can you get it? So 153 to 1. Again, we did not include this 13.5, the whole 95% because it is not asked in the problem. Only 153 to 174. Okay, so that is how you're going to solve example number 2. I hope you get it. Then if you have questions, just comment or PM me about that questions. Okay, so that is about the empirical rule. So I hope you learned something from this video. I'm going to continue to our next lesson on the next video. Thank you and God bless.